This is Dan McNerney's final submission video for Omega Race. I'm going to take a little bit of a tour through the program and take a look at how it works. Right now I'm going to be running it natively on a computer. But it does work on a network connection just the same way as long as it's on the local net. So I'm going to go ahead and start up 2 instances. You can notice at the very top the instance named itself server. The way my networking works is it goes and it pings out to the local network and sees if there's another copy of Omega Race running. If there is, it connects as a client. If there is not, it connects as it makes the assumption that it's the server, and then it begins listening for client connections. I'm going to run another instance, and that's going to pop up, and we're going to see it name itself the client. I'm going to try to reposition these so we can see them both. All right. On the server, when we go ahead and press space to go to the next state, we're going to load into the game itself. Now I'm on the server and I can move around. I've left controls on both client and server the same. And I can move, I can shoot some ships, I can go over to my client, and I can drop some bombs, shoot some ships, and let's see if I can get a nice little shot here. I think I saw a little spurious explosion on the client side because it still has some physics bodies associated to it, but client side we were able to shoot the server and get points and get credited for it, and the points and credit are the same on both sides. And we're going to go through, walk through this. I wish that this guy wasn't moving as much. It's going to be a hard target, but once I shoot him, he will lose his momentum when the round ends, and then we'll go through. Collisions are modeled on both sides. My thought process was that the missiles and bombs are entirely deterministic, and the ship instead is just giving hard updates from the server about what it's the server sends the client its actual position literal and angle literal. So if the ship ever were to become desynced, it would be resynced on the very next frame. And as such, the system is entirely deterministic for the client once the server's data is known. So my thought process around that is that I could leave the collision system up. Oh, and it looks like collisions are no longer firing on the client side. That's interesting. They do to shots, but not to ship collisions. I didn't realize that. Well, if I had more time, I'd take a look at that. I was just impressed with the fact that I can make nice glowing walls whenever I shoot them on the client, and then I'm going to shoot them one more time. And that's going to take us to round end, and then the client, I don't have the game state as fully fleshed out as I'd like it to be, so the client is going to fail after I press space. And the client doesn't follow suit. Oh, that's actually surprising to me. Typically it throws an error. Maybe that was just a lucky happenstance that it didn't. Very interesting. Okay, so let's go take a look at Omega Race. So when the game boots up, it goes through, and the first thing it does is it goes to initialize the network. In here, what it does is it either computer, there's no difference between the two programs. Either one could be a client or it could be a server. So what we do is we set ourselves up for a client connection. And then we go try this connection, and this is basically us shouting across the local network 10 times with a little delay in between each one to try to see, using this nice beautiful LitGrid setup, to see if anybody responds that there's a server running. If there is, then we'll work out that a connection was made on such and such attempt, which usually comes out as 3 or 4. If not, it's going to count up to 10, sleep a tenth of a second, and then keep going through. If it finally bottoms out, if it shouts 10 times and no one responds, it determines that it is the server, and that's going to happen right back up here. Nope. Right here, after try connection, if the client connections count as 0, then we are the server. We are going to take our client connection and null it out, and then we're going to set up a new connection, and we're going to set that up as the server. Using our server reference. And then we're going to do server start, and we're going to start listening for connections. So then we go through, we see a lot of the normal game stuff. Update. Now the big change to the update is that Depending on whether or not you're client or server, we do a network update at the very end. So there's a server messaging update and a client messaging update, because clients and servers respond to messages differently, as opposed to having just one network manager that can answers everything under the sun. And differentiating by having server messages and client messages. Okay. So, next thing we're going to take a look at is input. So here is kind of our play screen inputs. So what we do is we take from the original kind of data-driven design, is that whenever we get an input, we go ahead and we store the value and we push into our input queue request to go ahead and do that movement. And this is what's actually going to execute the movement, is once that's processed out of the input queue. Going down, we can see some differences between client and server behavior. So when player 1 fires, if you're the server, we're going to push a spawn missile command. If we are if we are the client, we're going to spawn a ship fire request instead, and we're going to take a look at the differences between those. And similarly for bombs, servers put in bomb or spawn bomb messages, and clients put in a ship bomb requests. So let's go up to take a look at our queues. So the network manager holds the in queue and the out queue, and is a singleton, just a point of reference for us to go ahead and push items into the in queue and process items out of the out queue. And it also allows us to push to the local out, which is very important for the server. Because oftentimes when the server is processing something out of the input queue, it will also push a duplicate to the output queue. So this process input is what's going to allow us to take an input and then process it and find out its behavior. So ship rotate request is nothing very fancy. We just push the local out that we'd like to rotate, and that unsurprisingly uses our local variables to rotate the ship. If we are the server. If we are the client, instead we go ahead and we write a rotate request to the server, and the server is going to interpret that natively as an output queue. Similar behavior with the thrust request. Server goes ahead and pushes it. Client go ahead and asks to push. Fire request. This is actually a misleading from previous builds. This should never be reached by the server. Instead, only clients send this type of message. So what the client does is it goes ahead and writes a ship fire request. It'd like to shoot from this ship. That goes to the server, and the server, it reads that in as a missile spawn request, in which case it pushes to local out that it'd like to fire a ship at this position, and it goes ahead and writes the positional data required to spawn a missile, and the client will interpret that and spawn it. So what's nice about that is that both the local out version and the spawn missile version are snapshots of the same exact point in time on the server. It'd be a lot nicer if I had a delay queue to make it so the server wasn't constantly running ahead of the client, but hey, that's just where we're at. And then the same pattern for bombs. Server goes ahead, should never make a bomb request. It just kind of, that was my pattern for development. Client goes ahead and makes a request to the server to make a bomb. If the server gets a bomb request, it goes ahead and pushes out a local copy, and then it goes ahead and writes a go ahead and spawn bomb based on that same exact data. Now the ship update, once again, the server pushes this data to itself. So we've delayed the ship update and made it go in through these queues. That way the same snapshot gets sent to the server as sent to the client. So we're pushing the ship update to our copy of our ship update so we can update our two ships. And similarly, if we are the server and we actually have a connection, this is like the little special glue that lets you play this game. You kind of run it without any type of connection, even without a second instance running on your PC. Then we go ahead and make a packet, ship packet, which includes the ID of the ship. So the IDs are synced on both games, and actually the IDs are set to reset on the ships to whatever their original set value is, which should always be 0 and 1, so that they're nice and easy to find. But we go ahead and send the ship ID, which we'll use to find the ship on the other side. We send them the X, the Y, and the angle, and those are just hard pushed in. So every frame, the client should be receiving a, with lag buried in there, but every frame the client should be receiving a position literal of the ship, and this allows them to stay in sync at the same time. Kill player, this is one of the ways that I take away the ability of the client to make any meaningful changes to the game. When a player is killed, only a server is actually going to put that into effect, and they're actually going to write the change. And our nice little state allows us to change to the play state. Okay, so our output events are not super exciting. They're just us processing output events, usually passing them. All we do with an output event typically is just pass it to our local machine. And then inside this network file, here is the ugly, ugly glue that makes all the networking work. So this client message update has how the client interprets all the behaviors, and then here's our beautiful Lidgren thing. Everything's inside of the data. So we have ship update. Here's where client's receiving that ship literal, deserializing it, and then go ahead and pushing the local event. An output event is typically a local event. Ship fire request, push to local out, a ship fire. Spawn missile. Here's where we get all the data for a missile, and we pass this little spawn missile based on that packet, because getting the direction was a little bit painful. We'll go back. Spawn bomb, kill player, and going down here, we've got the rotate request, the thrust request, the fire request. This is inside of the server messaging update. We've got rotate request, ship thrust request, ship fire request, ship bomb request. So I'm going to fire this up really quickly on both of these guys. I don't think I'm going to play through the whole thing. Oh, the old one's still running. I'll go ahead and kill that and pop it up again. And there's our client. And I'll just play this out on the client. Oh no. As I said, controls are still on both. Also written out, so I might have a little issue with that. It gets lost when it goes and does add point. It might be losing the game IDs. Or I might not be able to see it through the little walls on this. Anyway, so yeah, that's basically the project. I don't think I have a lot more to say, so thank you very much. I know I'm running a little bit over. Thank you.